Assalamualaikum and greetings to all. Today's topic is on triple integrals in spherical coordinates, where the variables that we're going to use would be theta, rho, and phi. Okay, let me write that for you. This is called rho. This is theta. You're familiar with that. And this is called phi. Okay, now let's see how we measure rho, phi, and theta. Well, for theta, it's the same way as you measure theta in cylindrical. Phi is measured from, so it's kind of an angle that you measure from the positive z-axis. Okay, and for rho, it's the distance between the origin straight line in 3D. Okay, it's different from r. R is the distance from the origin that you measure on the xy plane, but rho here is in 3D, xyz space. Okay, now let's look at the relationship between rho, phi, theta with x, y, and z. Okay, so the first one is this: x squared plus y squared plus z squared is rho squared. As you know, this is an equation of a sphere. This is equation of a sphere where the radius is rho and the center of the sphere is at the origin. Okay, now let's look at this triangle. So here we have a right triangle. All right, and here for cos phi, cos phi is going to be the adjacent, which is that z, and the hypotenuse, which is rho. So from here we get z is rho cos phi, this one. Okay, so now we have the length for z in rho and phi. This is rho cos phi. Okay, now for sine phi, this is phi, this is a right triangle. Okay, for sine it's opposite divided by rho. Okay, so this bit here is rho sine phi. Okay, so this is like zp over rho. So zp is rho sine phi. So this length here is rho sine phi. Okay, next is well, this length here, this straight line with that straight line is parallel. Okay, so if it's parallel, then they have the same length. So this is rho sine phi as well. Okay, now if you draw a right triangle here, okay, then we can get x and y. So this length here is y, and here that's an x, right? This length is x and this length is y. Okay, using the right triangle, we can get cos theta. Cos theta, this is theta, so cos theta is going to be adjacent, which is that, divided by hypotenuse, which is rho sine phi. So from there we get x is rho sine phi cos theta, which is this. And you can do the same thing for sine theta. Okay, for sine theta, it's opposite, which is this length here, which is a y, divided by hypotenuse, which is rho sine phi. And then from there we get y is rho sine phi sine theta, which is that. Okay, all right, so now let's look at how do we sketch theta equals a constant, rho is equal a constant, and also phi as a constant. Okay, let me erase this, too much there. Okay, let's start with something that you're familiar, which is theta. Okay, I need more room. Okay, so theta, as you know, it's how you measure theta is the same way as you measure theta in cylindrical, you start from the positive x-axis, anti-clockwise direction. So when you have theta equals a constant, what you have is really a vertical plane. Okay, so for example, this is xy plane, and here we have xyz space. Okay, this is x-axis, y-axis, and z-axis. Okay, this is x-axis, y-axis, and z-axis. Okay, for theta equals a constant, if you remember from polar, you measure theta from positive x-axis, anti-clockwise direction. So this, for positive x-axis, theta is 0, and here this is theta equals pi over 2, and on the negative x-axis theta is pi, okay, and here theta is 3 pi over 2. Okay, so now let's do that in 3D xyz space. So we still start with the positive x-axis, this here. So in 3D we would have a plane, vertical plane. So this is theta equals 0, and here on the positive y-axis, this is theta equals pi over 2. Okay, and right here a vertical plane there, so this is an angle pi, so that plane is going to be theta equals pi. Okay, and you know the drill. Well, if it's pi over 4, then it will be in between these two planes. Okay, so theta equals a constant will give you a vertical plane. Okay, I think it's easier to understand because it's very similar to cylindrical coordinates. Okay, now let's look at rho. What happens when rho is constant? Okay, rho constant, what you have is a sphere. Okay, so remember how we measure rho? Oh. We measure rho from the origin, and then draw a straight line in xyz space. So when rho is a constant, if you do that combination of all the straight line from the origin, what you get is a sphere. Okay, so here we have xyz space, say y-axis, x-axis, z-axis. So if this distance here from there to there is 1, from here to here is 1, 1, 1, okay, and here we have a 1 as well, then here we have a 1, so all the distance between the origin is 1, so you end up with a sphere, a very beautiful sphere, I might say. So let's say that's a 1, so this is rho equals 1. Okay, and so here if half of that, then you have a smaller sphere, so that would be, so let's say that's a half, then this is rho equals a half, and so on. So when rho is a constant, what you have is a sphere. Okay, now let's look at phi. Okay, how you measure phi? Phi is measured from the positive z-axis. Okay, so phi is measured from the positive z-axis. So if phi is a constant, what you have is really a cone. Okay, what you have is a cone. For example, let me draw xyz space here. Okay, let's say here we have y-axis, x-axis, and z-axis. Okay, we measure phi from the positive z-axis. So let's say this angle here is pi over 6 or 30 degrees, and here is an angle that you measure from the positive z-axis. So this is also pi over 6, and if you do it forward and backward, combine them together, what you get is a cone. So this cone is phi equals pi over 6. Okay, now let's say this angle here is pi over 4 or 45 degrees, and here we have this angle is also pi over 4, and if you do that forward and backward, combine them together, then you have another cone. Okay, so this cone is phi equals pi over 4. Okay, now for pi over 3 it will be a bigger cone, but then let's say here we have, this is from the positive z-axis to the positive y-axis, that is 90 degrees, and here positive z-axis to the negative y-axis, that is also 90 degrees. Positive z-axis to the positive x-axis, that is also 90 degrees, and this is also 90 degrees. So if you connect them together, what you get is a plane, or you can draw it in rectangle or triangle, whatever, as long as it's flat surface parallel to the xy plane. So this is phi equals pi over 2, because the angle between the positive z-axis to here, that is 90 degrees. That is also 90 degrees. This is also 90 degrees. So it's all pi over 4. Okay. All right. Now, if we make it larger, okay, let's say running out of okay. Let's say here we have another cone. Okay, and this angle here is from maybe I should draw this in different, never mind. So let's say this is 45 degrees. This is 45 degrees, pi over 4. This is also pi over 4. But you measure rho from the positive z-axis. So from the positive z-axis, let's say from here to this cone, that is really pi minus pi over 4. So this angle from here to there, you can do it this the other way around, from here to there, okay, is pi minus pi over 4, which is 3 pi over 4. So this cone is phi equals 3 pi over 4. And if you go all the way, pi phi equals pi, then what you have is the negative z-axis. So from there, if you measure from the positive z-axis all the way to negative z-axis, either from left, or you can do it this way, okay, you can do that as well, then this is phi equals pi. Alright, so you can't go larger than pi. So the range for phi is from 0 to pi. So 0 is on the positive z-axis, phi equals pi is on the negative z-axis, which is an area from the positive z-axis all the way to the negative z-axis. So the angle is pi. Okay, all right. But for theta, as I draw theta before, for theta, the angle, it can go from 0 and then all the way back to the positive x-axis again, which is one rotation there. So theta can be from 0 and then to 2 pi. So that's the range. Okay, so then we have this. Theta is from 0 to 2 pi, phi is from 0 to pi, and here x squared plus y squared plus z squared equals rho squared is an equation of a sphere with a radius rho, and the center is at 0, 0, 0 at the origin. But of course, if you have a sphere of the same radius but the center is not at the origin, then rho is not equal to a constant. And these are the relationship between x, y, z with rho, phi, and theta. Okay, I'm going to save this in the next video. Thank you.